Good morning, good afternoon, good evening. Welcome back to Chapter 2, Chemistry. We're talking about how atoms will link together and form these things that we call chemical bonds. We said in the last video that electrons orbit the nucleus of the cell. Just made a mistake. It orbits the nucleus of the atom. If you remember the last video, I just said that electrons orbit the Georgia Dome. Electrons orbit the nucleus of the atom. They orbit at certain distances away from the nucleus. That's not terribly important. The most important part about this is remembering that orbitals are grouped into shells and that an atom wants to have its outer shell filled. That's the most important part to know and to understand. Atoms want to have their outer shells filled. If they don't naturally have their outer shell filled, that means they will engage in relationships with other atoms to fill them. And there are a few of these different relationships. This shows each of these circles represents a shell. We said in the previous video the first shell only has one orbital, and therefore the first shell can only hold 2 electrons. And so here we see hydrogen. It only has 1 electron because what is hydrogen is element number? Hydrogen is element number 1. If it is element number 1, that means it has how many electrons? 1. 1 electron. So it only has the first shell and only has 1 electron in that first shell. How many electrons does hydrogen want to be happy? It wants to have a total of 2. So how many more electrons does it need? Hydrogen needs 1 more electron to be happy. This shows lithium. Lithium is element number 3. It's element number 3, which means its first shell, which can hold 2 electrons, is full. Well, now that it's filled this first shell, I open up the second shell. And we said in the last video, the second shell can hold 8 electrons. And how many electrons does lithium have to put in that second shell? And the answer is, well, it only has 1. And we'll talk a little bit about that as we get further on. So you can look at these on your own, and each different ring represents another shell. And as we said before, each shell is larger than the last one. The first shell can hold 2 electrons, the second shell can hold 8 electrons. I was about to ask if there's any questions. If there are, write them down and email them to me. That's a really good point. When you are watching these videos, have a sheet of paper next to you. There's going to be stuff I talk about that you don't get. Hey, what did you mean by blah? Write that question down, and then either A, email it to me, or B, and better, write it down on the Discord server. Put it in Discord, because if you have that question, somebody else has that question too. And you'd be saving me a lot of trouble, so I could just answer it once instead of 6 times. So, if you're not on Discord, get on Discord. 2, when you watch these videos for the rest of the semester, keep a sheet of paper next to you to write questions down. And do still take notes as though you would be in a normal class. Watch the video, take notes like you would. Writing stuff down helps you to remember it. We said that atoms want to have their outer shells filled. If an atom does not naturally have its outer shell filled, it will engage in a relationship with another atom to fill it. We call those relationships bonds, chemical bonds. The outermost shell is called the valence shell. Each atom wants to fill it. And how full it naturally is changes the behavior of any given atom. How full the valence shell is determines the behavior of any element, of any atom. Because if it naturally has a filled outer shell, it really doesn't want to be in a relationship with anybody else, because the only reason why they do these bond things is to fill their outer shell, and if theirs is naturally filled, then they don't care. They don't want to do anything. If it's almost filled, An atom is going to be rabid. An atom is going to be fierce about trying to fill that one last spot to fill its outer shell. If an atom has only just opened up a brand new shell that's got a whole bunch of slots in it, but it put one electron in this shell, how bad does it want that one extra electron? What are the chances it's going to be able to get a whole bunch more electrons to fill all the rest of these slots? And the answer is not very well. So if it's almost filled its valence shell, it's going to be very, very strong in how it reacts, how it pulls for electrons. If it's only just opened up a brand new shell with just one electron in it, it's not going to pull very hard for that one last electron. I'd rather just get rid of it and fall back on the filled shell below it. The three kind of bonds are defined by the behaviors of the atoms in the bond. If the atoms are equally sharing the electrons, it's called a covalent bond. Co for they're working together like a company. Valent for that valence shell. So a covalent bond means the outer shells of these two atoms that are engaging in a bond together basically kind of fuse together. And so the electrons will then orbit both of the nuclei. And a really good example of this is methane. So here's carbon, and here's one of the electrons in its outer shell that it is willing to share. Hydrogen has how many electrons? 1. So it will donate that one electron that it has. And now this pair of electrons, remember electrons want to be paired. Now this pair of electrons will orbit both of the nuclei, both of the atoms. Carbon is actually willing to do this with 4 hydrogens. Here's another electron it's willing to share. Here's a second hydrogen. That hydrogen will donate its one little electron to share it with carbon. And now this pair of electrons will orbit both of these. Here's another electron carbon's willing to share. Here's a third hydrogen with its electron. Now this pair will orbit these two. And lastly, I kind of ran out of room here. There's that last of the 4 carbons willing to share. Here's my 4th hydrogen. It will donate its one little electron, and now this pair will orbit these two. So this is what CH4 means. It means that carbon is sharing 4 pairs of electrons with 1 hydrogen each. 1 hydrogen, it shares a pair of electrons, and it does this with 4 separate. Carbon and hydrogen have roughly similar pulls for electrons. They really don't pull any harder, which means it is an equal sharing. An equal sharing between these two elements. Well, what if I don't have an equal sharing? What if I have like a relationship between oxygen and hydrogen? Oxygen is a bit of a bully when it comes to hanging on to electrons, and it will actually hold on to electrons a little harder than carbon does. So here's my oxygen. It has an electron it's willing to share. Again, hydrogen donates its one little electron to oxygen. So now we have a pair that will orbit both of these nuclei. But the difference is between carbon and hydrogen, it is equal. But between hydrogen and oxygen, it is not equal. Oxygen will actually keep the electrons most of the time. Oxygen will do this with 2 different hydrogens. There's the other electron hydrogen is willing to share. Here is a second hydrogen. There's its electron it's willing to share. And again, same circumstance, and that is that the electrons, they're shared, but they're not shared very evenly. Oxygen hangs on to the electrons most of the time. All right? And so this is called unequal sharing. It's kind of like how your big brother shared the Xbox with you when you were little, right? Who got to play most of the time and who got the controller that wasn't plugged in. Unequal sharing. All right? Oxygen and hydrogen. Oxygen has a stronger pull for electrons than hydrogen does. So it holds on to the electrons longer. And what this actually ends up doing is it ends up giving oxygen a little bit of a negative charge because most of the time it has electrons that it didn't start off with. And if I'm holding on to negative charges I don't normally have, that will make me partially negative. So oxygen is partially negative. Well, what's happening then to these hydrogens? If they have lost their electrons most of the time, if they don't have a handle on these negative charges that they're supposed to have, that means they're going to be partially positive most of the time. Okay? Electron is partially negative. Oxygen, excuse me, did I say electron? Did I really say electron? Oxygen is partially negative. Hydrogen is partially positive. And both of the hydrogens will have a partial, it's not a full positive one, it is a partial. A partial positive charge. Okay? This is what being a polar covalent bond is all about. Polar means it is unequal. It has poles, just like the north and south pole of a magnet. The north and south pole, if you try to push the two north poles together, they won't go. If you try to push the two south poles together, they won't go. You have to put the north and the south, two different areas, and they'll go together. Positive and negative, two different areas.